So I've got this box being pushed across the floor, and I'm looking for the coefficient of friction as it goes across the floor. My strategy for something like this, because I have all these forces, is to sum up all the start with the free body diagram, sum up the forces in the x and y direction, and then, because this particular problem asks about the coefficient of friction, what I need to do is introduce that variable into my equations using the definition of friction. So I'll use that in order to solve this. Let's start with the free body diagram. All right. So this represents the box. Now I want to represent all the forces acting on the box. So the earth pulls it down. That's going to be the weight. Now you see my other videos, you know I keep writing W instead of, I keep writing mg instead of W for the weight. But because this one actually gives me the weight of the box itself, I'm going to leave that as W this time. So here's the weight of the box. Now the box is sitting on a surface, so the surface is going to exert a reaction force to keep the box from sinking down into it. And that reaction force is called the normal force. And the normal force acts perpendicular to the surface. That's what the word normal means. Normal means perpendicular. So I'll give it a little dotted line just to kind of show that that's where the surface is itself. Okay, what else do I know? Oh, I've got the person pushing itself. So that's going to be a force going this way. So I'm just going to call that F kind of by itself. And let's see, do I have a net force on this particular problem? No, I actually don't, because it talks about it moving at a constant velocity. Constant velocity means no change in velocity, so no change in velocity, no net force. Now I've got friction. Friction opposes motion. So this guy is pushing from left to right, or this person, I guess, is pushing from left to right, and friction is going to oppose the motion itself. So that'll be friction. And friction always acts parallel to the surface, which is why it's in this direction. And I'm going to use a cursive F to represent the force of friction itself. So there's my free body diagram. Now let's start with summing up the forces in the x and y directions. All right, sum up the forces in the x direction equals, well, it either equals ma, because there's a change in velocity, or 0. So in this case, it's moving at a constant velocity. I circled that earlier. So that's going to be equal to 0. So the sum of the forces in the x direction is going to equal 0. And that's going to equal all the forces going to the right minus all the forces going left in this case. So the force of the guy pushing minus friction. And then I'll sum up the forces in the y direction. That equals, well, it's not changing speed in the up and down direction. It's staying in the same horizontal direction, so nothing there. And that's equal all the forces up minus all the forces down. That would be the weight. All right, so that's easy enough. Now, in order to complete this, you can see I don't have the variable mu anywhere in here. So what I need to do is use the definition of friction in this problem. So I'm going to use F is equal to mu times eta. So from here, everything else is just math. And there are lots of ways to get the final answer, lots of ways to set it up. So I'm just going to show you one way that I do a lot of times when I'm solving these problems. Start with, let's look at the equations that I have. I have friction is equal to, the force that he's pushing with is equal to friction. So this is the first equation with summing up the forces in the x direction. Summing up the forces in the y direction, I know that eta is equal to the weight. Well, I just move it over on the other side of the equal sign. And of course, I have the one in blue, F is equal to mu times eta. So here's what I'm going to do. I'm going to take my friction that's up there, and I know that down here, friction is equal to mu times eta. So I'm going to take my friction, let's see, like this, and replace it with mu and eta. So that means that the force that he's pushing with is equal to mu times eta. That really didn't get me very far. But what I also know is that the normal force is equal to the weight. So I'm going to replace the weight where eta is located. So now the force is equal to mu times the weight. And I'm looking for mu, so this is actually a pretty quick problem to solve. Mu is equal to the force I'm pushing with divided by the weight. So let's see, it's being pushed by a force of 400 newtons. Nope, that's wrong. Let me erase that real quick. It is being pushed by a force of 200 newtons. Let's go with that. 200 newtons, and it weighs 400 newtons. That's better. So that equals 0.500. So the coefficient of friction is equal to 0.500. No units, on the coefficient of friction. It's just a percentage of the normal force. So 50% of the normal force goes into friction.